This is part 2 of explaining engine head series, and in this video we'll look into the port's shape and size and why they matter. If you have seen an animation of a 4-stroke engine, you would have noticed that the ports are illustrated as straight from the side and making a sharp 90-degree turn. These ports are just a stereotype, to be honest. On the other hand, if you have seen a high-performance engine, you would think that straighter is better. But sadly, the reality is not that simple. To understand why, we first need to understand the fuel delivery system. On a carbureted engine, the ports aren't actually that straight. This is because carburetors work by accelerating the air through a venturi, also known as a converging-diverging nozzle, and it utilizes the Bernoulli principle. I won't go into detail, but in short, it accelerates the air, and since air has lower pressure when it's moving fast, this draws in some small amount of fuel from a nozzle. So engines with carburetors benefit more from having curvier, smaller ports to create a higher velocity. This velocity, also coupled with the 90-degree-ish bend, causes the fuel to smash into the walls of the port, atomizing it better and making a better mixture. The drawbacks is that at high RPM that curve becomes a choking point. Having a straighter port like this one right here I have made reduces choking points and provides more air volume. This is what makes high RPM possible. Having the valves at an angle also assists chamber filling. So let's take a look at an extreme example when it comes to ports. We have the Ferrari F1 2004 engine, and we'll compare it to a normal economy engine. The F1 engine has a really short, almost straight port. What it does, it delivers maximum amount of airflow. So straighter is better, right? Well, not actually. See, an F1 car idles at 4000 RPM. Diesels don't usually even rev that high, so they give zero shits about low-end torque. If you want a practical engine that can push a car at 1000 RPM, you need faster air. There are two ways to achieve this. The first way is that you make the stroke really long. The second is that you make the port really long with a smaller cross-section. Having a cone-shaped intake forces the air to move faster. This gives it more torque at low RPM. Making the intake variable in length gives you the best of both worlds. So the takeaway from this short video is that a carbureted engine may benefit from a curvier port, but most of the engines have no reason to use a curved port, as a longer or a variable intake manifold does the same job as the curved ports. The only reasons manufacturers may use a curved port is because the engine doesn't rev high, so they save space by using a curved port, or simply performance isn't really the goal.